Hello, I'm Pushkar and I'm discussing KVPY 2020 S6 Part 1 Chemistry paper. Here is a very interesting question, very in-depth question about the chemical reaction and Gibbs function. Products are favored in a chemical reaction taking place at constant temperature and pressure. Consider the following statements. So, a reaction is happening at constant temperature and pressure. Products are favored in which of these cases? They are asking this. Change in Gibbs energy for the reaction is negative. The total change in the Gibbs energy for the reaction and the surrounding is negative. Change in entropy of the reaction is positive, and the total change in entropy of the reaction and surrounding is positive. So these are the four different statements. The examiner is trying to confuse you, try to see the depth of your knowledge. Okay, so let us see what happens when a reaction goes to the equilibrium. Suppose we have a reaction, a simple reaction, A moles of A plus B moles of B is changing into C moles of C plus D moles of D. So when this reaction approaches equilibrium, if it is approaching equilibrium, the first thing is the delta Rg, which is equals to C times of Gc plus D times of Gd minus A times of Ga minus B times of Gb must be negative, must be negative or less than 0. Where Gc, Gd, Ga, Gbs are what? They are Gibbs function, molar Gibbs functions of A, B, C, and D respectively. Small a, small b, small c, small d's are what? Stoichiometric coefficients. And keep it in mind that Gc, Gd, G, and Gb are variables. They keep on changing. Suppose the pressure of A is Pa at an instant, pressure of B is Pb at an instant, pressure of C is Pc at an instant, and pressure of D is Pd at an instant, then Pc, Pb, Pa, Pds are changing, so are the Gc, Gd, and G and Gb. So that's a very dynamic situation. When the reaction progresses the equilibrium, all these quantities changes, and if this is negative, it goes on changing because reaction goes on and goes on moving into the forward direction. During this situation, what about the delta Rg surrounding? Because in one such question it has been asked, what about delta surrounding? Delta Rg surrounding. So of course, delta Rg surrounding is always going to be equal to delta Rg system but with negative sign. Because as we know, there is no point talking about the surroundings Gibbs function. We can talk about the surroundings entropy, but the Gibbs function is created in such a manner that you don't need to answer the you don't need to check the surroundings Gibbs function. So examiner is trying to confuse you when he is asking you delta Rg surrounding. If someone asks you what is delta Rg surrounding, this is simply delta Rg system with negative sign. Okay, got it? So obviously, for reaction to reach equilibrium or reaction to approach towards equilibrium, delta Rg should be negative, and this is basically what? This is delta G of the system. And we obviously don't require anything regarding the delta G of surrounding. So coming back to this one, which options is appropriate? Change in Gibbs energy for the reaction is negative. Of course, it should be negative. If it wants to get to the equilibrium, it is moving in the forward direction. Okay. Products are favored. That means delta G of the reaction is negative. That's why product is favored. Total change in the Gibbs energy for the reaction and the surrounding is negative. We could not say it will be zero. It will be zero because whatever change is there. So this statement is obviously wrong because in this case, total delta G total will be what? Will be obviously zero. Third is the entropy, change in entropy of the reaction is positive. We could not say that change in entropy of the reaction is positive. The reason being is this. Suppose we take an example of this reaction N2 plus 3H2 changing into twice of NH3. Under certain situations, the delta Rs of this process could be negative. More number of gases are forming few number of moles of gases. So obviously, more number of gases are forming few number of gases, delta S can be negative. But at the same time, this delta Rs is basically delta S system. If we talk about in the same reaction, delta is surrounding here, that is equal to minus delta RH by T. Suppose this reaction is exothermic. If this reaction is exothermic, if delta RH here is equals to negative, That means this quantity is what? Basically, this quantity is positive. So the positive number of delta surrounding and the delta system, which is negative in this case, if addition of these two is yielding you a positive number, that means what? The entropy of surrounding, entropy of the universe is increasing. And that is why this reaction is going in the forward direction. So the idea is, when you talk about the entropy, you talk about the systems and surroundings entropy. When you talk about the Gibbs function, you only talk about the Gibbs function of what? The system. That is why the Gibbs function is created. So looking into this or these options, the change in entropy of the reaction is positive, not necessary. Maybe it could be negative and still reaction can proceed in the forward direction. So we will not choose this three. Okay. The total change in entropy for the reaction and surrounding is positive. Okay. And the statements which are always true, this is written. So the statement 3 can be true but not always true. That is why we could not select it. And fourth option we have to select it. Okay. So the correct option seems to be 1 and 4. So 1 and 4 is basically the B option. So B option is the correct option. Fantastic question. It is testing your fundamentals and it's very important to understand this fundamentals. Answer is B. Thank you for the watching and stay tuned for detailed discussions of questions in this paper.